This just in, we have found out from the World Health Organization that a change in water could pose a serious threat to mankind. This is Helen Schilling, and let's discuss. First off, let's go through how water acted before the shocking change. One singular water molecule is made up of two hydrogen molecules and one oxygen molecule. The electronegativity, or the measurement of an electron's attraction between oxygen and hydrogen, is 1.4, which makes the bond extremely polar, or the bond's energy is not shared equally between hydrogen and oxygen. These water molecules bond with other water molecules to make hydrogen bonds, which are the strongest bond inside of molecules. This is called an intermolecular force. Hydrogen bonding takes place with hydrogen and nitrogen, hydrogen and oxygen, or hydrogen and fluorine, to make a very strong separation of charges. But for some reason, these strong hydrogen bonds have broken and transformed into weak London dispersion forces, which happen to be the weakest type of intermolecular force. London dispersion forces contain electrons that bunch up and create a small temporary separation of charges with nonpolar bonds, which are bonds that are shared equally with a small electronegativity difference. Okay, so let's break down how water actually changed since this morning. First, since the change from water-hydrogen bonding to being a London dispersion force, water's boiling point has changed quite a bit. Before the change, water had a very high boiling point due to the polar hydrogen bonds that are in every water molecule. With such a high electronegativity difference within the hydrogen bond, the electron grows more resistant to change, thus more resistant to a change in temperature. But since the water bonds have turned into London dispersion forces, which are nonpolar bonds, water's boiling point is now much lower. With hydrogen and oxygen being shared equally in the water's bonds, the water can heat up much faster. So please stay safe around water, folks. Now, let's discuss water surface tension. Surface tension is the resistance of a liquid to spread out, and typically the stronger the intermolecular force, the more surface tension. This is true because in polar bonds, the forces are not equal, causing more force on one part of the bond. This creates a resistance for the liquid to spread out. So, before this change of water had a high surface tension due to the strong hydrogen bonds in water. But since this morning, water has a low surface tension, similar to different alcohols with a low surface tension as well. With water containing the nonpolar London dispersion forces now, the force within these water bonds are evenly spread out due to their nonpolarity, so they have much less resistance than before when water could hydrogen bond. So, continue to watch out for water today. Another key point to bring up is water's solubility. Before the crazy events that took place this morning, making water's bonds a London dispersion force, water was a great solvent due to its strong polar bonds, making it able to dissolve other polar bonds such as salt. The rule when talking about solubility is that likes dissolve likes. So polar bonds can dissolve polar bonds and nonpolar bonds can dissolve nonpolar bonds. But after this morning, with water changing into a London dispersion force, water solubility looks much different. London dispersion forces make weak nonpolar bonds. So now water cannot dissolve other polar bonds, but rather only nonpolar bonds. This will change many compounds within our life and how they look like now. Like water cannot dissolve things such as salt because salt is a polar bond. So there could be no salt water. Finally, we need to discuss the change of water's specific heat. To explain, specific heat is the amount of heat something takes to make an increase in temperature. And before the switch of water's bonds, water had a very high specific heat. This was due to the hydrogen bonds contained in water that make those bonds highly polar and resistant to any kind of change, thus giving it a high specific heat or forces needed to make an increase in temperature. But since this morning, with water now containing London dispersion forces, water has a much lower specific heat because London dispersion forces are non-polar bond and the force is shared equally, making those kinds of bonds way more susceptible to change, thus giving the new weaker water a lower specific heat. To conclude, we urge you to be careful around water because of the many changes that have been documented since water now contains these weak London dispersion forces. Please stay safe and thank you. This is Helen Schilling signing off.